So let's look at the reaction between hydrogen and oxygen, one of everybody's favorite. And in this reaction, if you looked at the balanced chemical equation, you would see you need 2 hydrogens for every 1 oxygen. So if you have a reaction where that ratio is different, as in the example that's illustrated above, then one of the reactants is going to be excess and one of them is going to be limited. So we're going to just run through and see how that's determined. So let's suppose in this case we have 10 moles of hydrogen, and we're going to figure out, well, how many moles of oxygen do you need to react with that? And so the ratio there is a 2-to-1 ratio, and you need 5 moles of oxygen to react with 10 moles of hydrogen. So we actually have 7 moles, which is a little more than we need, and so we say that the oxygen is excess. And you can see there's a couple leftover oxygens on the product side. That's what we mean by excess. They're left over. So by default, that means that in this example, that the hydrogen is in limited amount. Notice that there's actually more hydrogen, but that actually is the one that is called the limiting reactant in this case. Okay. So let's take a look at a slightly more complex problem. In this example, we are given 4 grams of hydrogen and 30 grams of oxygen. And so the first step is to convert from grams to moles. So we do that like we always do, and you'll see that we have 2 moles of hydrogen. And likewise, we're going to convert 30 grams of oxygen into moles, and that turns out to be just under 1, so 0.9375 moles of oxygen. Now, that represents the amount of hydrogen and oxygen that you actually do have. And now we're going to kind of enter the world of theory and figure out, based on the hydrogen here, how much oxygen do we actually need in this reaction? So, we need to have 1 mole of oxygen to react with 2 moles of hydrogen. So we're going to compare the amount of oxygen that we need to the amount that we have. And it's kind of like thinking about the cost of something you want to buy and the amount of money you have in your pocket. And in this case, the oxygen is limited. And again, that means that the hydrogen must be excess. The amount of product you will get is always determined by the thing that's in limited amount. So that's why we actually go through the bother to figure out which one is limited. And so from here we're going to continue on and figure out how much water can be produced in this reaction. And so we'll start out with a 0.9375 moles of oxygen, the limited reactant, and go through the same normal stoichiometry here. And you can figure out how many grams of water should be produced in theory. And that's called the theoretical yield. Now, in an experiment, if you were to run this, you almost always get a little bit less than the actual theoretical yield, and that's sometimes known as the experimental yield. And calculation that often a student might be asked is to calculate the percent yield. So the percent yield is like calculating pretty much any other percent. You're going to take the actual grams of water obtained, divide that by the theoretical yield, or grams of water that were actually produced in theory, and divide them, multiply it times 100, and in this example we get 98.1% yield, which is pretty darn good. So that's a basic example of a limited and excess problem. They get a little bit more complex in terms of the formulas, but basically they're all the same